Alright, this video is to help you with the buffer solution lab. This is the first page of it, just to remind you. Buffers are combinations of a weak acid and a conjugate base, or a weak base and its conjugate acid, and they are able to minimize changes in pH when strong acid or strong base is added to a mixture. And so in this experiment, you looked at some non-buffered solutions, water, and NaCl, and you added hydrochloric acid and sodium hydroxide, drops of each to those two, but to the pure substance water and to the solution of salt, and you saw what happened to the pH. And then you did it with buffered solutions, one being a mixture of acetic acid and sodium acetate, and then the second being ammonium chloride and ammonia. And you completed this data table. So you should have pH measurements for the initial pHs, and then after adding drops of HCl and NaOH to water in each of the solutions. Alright, and so the questions you were asked to answer, I do have number 3 kind of bolded and underlined because I did want to remind you that you do not have to do number 3. It was a duplicate and I missed it. I'm sorry. So I'm going to take it out. Well, I'll take it out the end. First thing it says, how did the addition of strong acid affect the pH of distilled water? And then you were asked to examine the pH readings for water and NaCl as drops of hydrochloric acid were added. How do these compare? And then you were also asked to do it for the base. If you haven't already done this one, you don't have to do number 1 because number 1 is basically the same as number 2 as well. So I'm going to go ahead and mark that one out. Give me 1 second. There we go. Alright. I can't mark out things well. There we go. Right one now. So you're going to look at how did the pH change? Did it go up? Did it go down? Did it go up rapidly? Did it go up slowly? Did it go down rapidly? Did it go down slowly? So look at those for number 2 and for number 4 for both the water and NaCl, and see if the changes that occurred for each of those were similar or if they were different. Did one change rapidly while the other one changed slowly, vice versa. And then it says for number 5, you're going to look at, and 6, you're going to look at the acetate buffer and discuss what happened for hydrochloric acid when it was added. Compare that one to the water. And then show me an equation where hydrochloric acid reacted with the buffer. Hydrochloric acid is a strong acid, so it's going to react with the base in your buffer. You had acetic acid and sodium acetate. Remember, the acid always has one more proton than the base. And so the net ionic equations I'm talking about are similar to these here in your notes. Sorry, I know it's cutting it off a little bit. This is from your PowerPoint. Here you have hydrofluoric acid and sodium fluoride. Hydrofluoric acid is your acid. The fluoride is acting as its conjugate base. So we would see the acid reacting with the base to make water and fluoride ions. Where here we see fluoride ions reacting with the acid, and you can write the acid as H+, that's fine with me. If you write it as H3O+, it would be making water and the conjugate acid. Okay? And so now you're going to do the same thing, but you're going to look at the ammonia and ammonium chloride, which, amazing enough, those two equations are actually already written for you here. You have the weak base reacting with the acid, making the conjugate acid of that weak base. And here you have the weak conjugate acid reacting with the strong base to make your original weak base in water. Okay? So you're also, besides writing the equations, which I just showed you for 7 and 8, so you should be good to go there, I want you to talk about how the pH for the water changed comparison to the ammonia buffer when you added hydrochloric acid. And the same again for sodium hydroxide. And honest to goodness, that's all this lab is going to require, so it's pretty straightforward. There's not a whole lot of, math per se, other than just looking at your data and interpreting what it's representing. in writing the equations for 5 through 8.